Hi there everybody, today we are looking at upper and lower bounds. Alright, so what we're talking about lower bounds is when a number has been rounded. Alright, the upper bound is the limit of the largest value, which is round to that number, and the lower bound is the smallest value, which will round to that number. Now I want you to be very, very careful in terms of what I'm talking about when I talk about certainly the upper bound, because we're talking about the limit. Alright, and I'll explain that a little bit because it seems to be always an issue with every kind of class that I've kind of come across when they've talked about an upper bound and they don't like it. All right, so I expect it's going to be the same case as I explain it over here. So I've got 32 inches to the nearest inch. Find the upper and lower bounds. All right, so the lower bound is the one that most people are fairly happy with, is that to the nearest inch, that means that it can go down to basically the first decimal point down to 31.5, because 31.5, when I round it to the nearest whole number, nearest integer, that would move up to 32, obviously because it's 5 and above rounds up. All right, so please look at the lesson on the rounding if you're not quite sure about that one, but essentially that's what we're going to do. So anything which is 5 and above rounds this up to a 2, so 31.5 or above would be basically 32 when rounded. Okay, the upper bound is the one that people don't like, and hence this big long thing here. It's actually the limit of the largest value, which would round down to 32. So it's actually going to be 32.5. Now, an argument is always a case of, well, it can't be 32.5 because that rounds up to 33. But the actual largest value would be 32.4999999999 recurring. But of course, I'm not going to write 32.49 with a dot on top to say it's going to recur all the time, because we're literally specifically looking at the limit. All right, and because of that, and because we are talking about bounds, basically limits, then our limit is 32.5. And actually, in terms of calculation purposes, we can't really work with this. So we work with this. So I want you just to literally accept when we're talking about upper and lower bounds and limits, we're going to use 32.5. And I know you might not like it, and I know you don't like it necessarily, and I agree with you. But as this in terms of the bound and the limits, we're going to use 32.5. All right, so anything less than 32.5 is going to be 32, and anything bigger than 31.5 is going to be 32. So they are our limits. All right, so upper and lower bounds. Okay, so when we're calculating with them, you've got to consider the fact that they've been rounded, and you've got to consider the fact that the numbers you are given aren't exactly as you see them on the tin. And unfortunately, in exams, people don't really read the question carefully enough to say basically to the nearest integer or to the nearest whole number or to one decimal place. They don't read it carefully enough, so that's what you've got to think about. Certainly in a higher paper, it often tricks an awful lot of people. People walk away from exams and they think they've done the question perfectly, and of course they haven't. So what they'll do here is A is 7, B is 10 to the nearest integer. What's the minimum value of AB? So they'll do, well, AB is A times B, so it's 7 times 10, so it's 70. And they'll walk away think they've done it correct. And of course they haven't at all, because we're looking for the minimum value. Well, to get the minimum value, I've got to consider what the smallest values of these could be. All right, because they've been rounded to the nearest integer. Well, the lower bounds of 7 and 10 are actually 6.5. That's the smallest it could be. And 9.5. That's the smallest value it could be. And timesing those two together is going to give me 61.75, which is significantly lower than doing 7 times 10, isn't it? It's significantly lower. But 7 times 10 is 70, but 6.5 times 9.5 is actually quite an awful lot lower. So the minimum value of AB is 61.75. That's actually my solution. What you've got to be careful of is division. Okay, when I'm timesing together, it's not a problem. I find the two lowest values for that previous case. But obviously when I'm dividing, you've got to start thinking about, well, what's going to give me the largest value here? All right. So what I mean is, to give me the largest value of C, because that's the top, then it's going to be 8.5. All right. But in terms of dividing, well, if I divide by the bigger number here, well, if you divide it by a bigger number, you're going to get a smaller answer. So actually, I don't want the biggest value for D. I actually want the smallest value. All right. Now you could look at all the different combinations of upper and lower bound and lower and upper bound and see which one gives you basically the largest value. But if you could think carefully in terms of, if I have the biggest and the smallest, is that going to give me the biggest answer? Well, in this case, if I have the biggest at the top and the smallest at the bottom, then it's going to give me my biggest answer. Okay, so the largest value of C will be when we take the upper bound for C and the lower bound for D. So that's the two we're looking at. So the upper bound for C, again, is 8.5, and I know you don't like it, but all right, but it's 8.5. And then D is going to be 4.5, and then 1 divided by the other, and it gives me 1.888 recurring. All right, so that's going to give my maximum value. Okay, so just be very, 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 very careful when dealing with questions about upper and lower bounds as to which ones you use. All right, if it times in, but obviously when divided, it really makes a big difference. All right, so please do go to maths-school.co.uk and obviously get some practice questions on there. But thanks for listening.